In Chapter 3, Section 2, we're going to expand on what we learned from Section 1, where we talked about power rule. Now we're going to talk about product rule and quotient rule. So they're also critical in the exploration of derivatives. All right, so for the first problem, it's going to kind of guide us through the quotient rule, which can be a challenge, so it's kind of nice that they gave us something to guide us. So it says, find the equation of the tangent line of the curve y equals 3ex over 1 plus x squared at the point 1, 3/2 e. Okay, so according to the quotient rule, so let me write what the quotient rule is. So if we have, let me not use f. If we have y equals two functions f of x over g of x, then what we call the quotient rule says this: the derivative of this will be f prime of x times g minus g prime of x times f, all divided by g of x squared. So oftentimes what I'll call it is fig minus gif over g squared. So we'll drop the of x part of it and just say you take the derivative of the top function times the bottom function minus the derivative of the bottom function times the top function divided by the bottom function squared. So in the function they gave us, it was 3 e to the x on top over 1 plus x squared on the bottom. I would call this f, and I would call all of this g. Therefore, f prime is just 3ex. It's the exact same as the original f. G prime, however, will simplify to just 2x. So the derivative of 1 is 0, and the derivative of x squared is 2x. So they're going to guide us through this. They left the bottom function alone, so they want the derivative of 3. They want the derivative of 3ex minus, so they switched the order on us, which I'm not a huge fan of, but it's okay. So then they did, let me actually write what they want us to do here. They left g and did the derivative of f. Then they did minus, they left f alone, and they want the derivative of g. Okay, so the derivative of g, and they say d dx, so they don't actually want the derivative of g yet, they just want the g function, which would be 1 plus x raised to the second. Okay, so then they say, okay, what is the derivative? So the derivative of 3ex is 3ex. And what is the derivative of 1 plus 2x? 1 plus x squared, it is 2x. Okay, and then they're going to want us to simplify that, expand that. So let's see what that would look like. We're going to have 3ex, so let me just write it over here, 3ex plus 3x squared ex. Then we're going to get minus 3, so minus 3 times 2 is 6 x ex, x ex. And that, unfortunately, nothing simplifies. We could factor out an ex, but I'm just going to type everything in and see what they think about it. So this would be 3ex plus 3x raised to the second ex minus 6x x 3x ex. Okay, then it says, so the slope of the tangent line at 1 3/2 e is what? So if we plug in 1 into this, so they want us to plug in 1. it would be e to the 1 plus 3e to the 1 minus 6e to the 1. So you get 3e1 plus 3e1 is 6e1 minus 6e1, which is 0. So that whole thing simplifies to 0. This means that the tangent line at 1, 3 has e is horizontal, and its equation is y equal to 0. Okay, so let's see if we got all those boxes right. A lot to check there. Okay, they didn't like my last answer, so let me take a look. Got ahead of myself a little bit there. The derivative is 0, but that's not the equation for the slope of the horizontal line. So the horizontal line is this purple line that they wrote here, and it's equal to just the y value of that point. So at x equals 1, the derivative is 0, but the original function, if you plug 1 into the original function, you get 3/2 z. So that horizontal line is described by y equals 3/2 e to the 1. So to get e there, you just type e to the first power. Okay, so that is problem 1. Okay, so interestingly enough, they don't want us to do anything with 2 other than simplify it. Doesn't even look like they want a derivative. So we have 45t squared minus t all divided by 9t. So this is a problem you could have done in college algebra. To simplify this, you're going to split up this fraction. So it's 45t squared over 9t minus t over 9t. So you can only do this if you have multiple things on top and one thing on the bottom, and they're separated by pluses or minuses. Now 45 divided by 9 is 5. And t squared divided by t is t to the first, and this would be minus 1/9. So those t's will cancel, and you just get 1 over 9. So to simplify this, it should just be 5t minus 1 divided by 9. So no calculus there, but what they're setting us up for is, instead of using that quotient rule I just showed you, which can be cumbersome, if you can simplify these fractions into separate terms, then the derivative is easy. So if I took the derivative of this as it is, it'd be pretty, not super hard, but it'd be a lot of work. But taking the derivative of the simplified version, the derivative is just 5. It's just the number in front of the t, because the 1/9 will become 0. So it's going to make the derivative much easier if we simplify first. That's the takeaway there. Okay, now in problem 3, you're tempted to do the same thing, simplify, but you cannot simplify this one. So if you have multiple things on top of one thing, you can simplify it, you can spread it out. But if you have one thing on top of multiple things, you cannot do that. So you cannot split this into multiple terms. So the best we can do is call this f and call the bottom g. And we're going to recall that y prime is fig minus gif over g squared. And I like to write all 4 things. So f is x to the 1/2 power, g is 1 plus x. Therefore f prime is 1/2 x to the minus 1/2. See video on 3.1 to see how I got that quickly. G prime is literally just 1. So if there's a 1 in front of this x, the 1 here goes to 0, and the 1x becomes 1. Okay, now we plug all 4 of these things into this formula up on top. F prime, which is 1/2 x to the minus 1/2, times g, which was 1 plus x, minus g prime, which is just 1, times the original f, which is x to the 1/2. And it's all over 1 plus x squared. Okay, the top is going to become, so I have to distribute this 1 and this x, and then this 1. So we're going to get 1 times 1/2 x is just 1/2 x to the minus half. And then we have 1/2 x to the minus 1/2 times x is going to be plus 1/2 x to the minus 1/2. This is x to the 1. Same base, different powers. So when you multiply them, you add the powers. So that's going to be plus 1. Then this is going to be minus x to the 1/2. And this is 1 plus x squared. Okay, now it turns out that this middle term, this minus half plus 1, will turn out to be plus 1/2. So we're going to have 1/2 x to the minus 1/2 plus 1/2 x to the positive 1/2 minus x to the positive 1/2 all over 1 plus x squared. This 1/2 x to the 1/2 minus this 1 x to the 1/2 is going to leave us with 1/2 x to the minus 1/2, and it's going to be minus 1/2 x to the positive 1/2 all over 1 plus x squared. And that is the I'm hoping that's all we have to type in and we'll get it right. Now there is potentially more simplifying we can do, but let's see if we can stop there and get it. Okay, and if you type it in exactly like I did, you will get it correct. So we luckily don't have to do any more simplifying than that. All right, problem 4. We've got another one. Again, it's one thing on top of multiple things, so we cannot simplify. However, actually, there is something we can do here. We do want to do some algebra to make our lives simpler. So this says x divided by x plus a over x. What we want to do is create a common denominator on the bottom, x squared plus a, all on top of 1x. So what I did was I wrote this x, let me actually show this in green. So I said I got to divide by x here, but if I do that I have to multiply by x on top. So that gives us x squared over x, and then I wrote the plus a all over 1x. And now we're going to write this as, this is the same as x over 1 divided by x squared plus a all over x. Well, you might have heard this before. We can keep, change, flip. So we can change a division symbol into multiplication if we flip the second fraction. Now we multiply straight across and we get x squared over x squared plus a. Now I think I bought us maybe a little simpler, but we still have to use quotient rule. So we're going to call this f and we're going to call this g. So f is x squared, g is x squared plus a, f prime is then 2x, g prime is also 2x. The a will go away because it's a constant, so the derivative of a constant is 0. So we're going to plug all this into the quotient rule, which says y prime is fig minus gif over g squared. F prime in this case is 2x times g, the original g, x squared plus a, minus g prime, which is also 2x, times the original f, which is x squared. And all of that is on top of the original g, x squared plus a squared. Okay, now we'll do some distributing, 2x into both of these, and then the 2x into the x squared, and we should get 2x to the third plus 2ax minus 2x to the third all over x squared plus a squared. And what we notice is the first term on top and the third term on top are exactly the same, opposite but equal, so they will cancel. So we're left with 2ax on top, x squared plus a quantity squared on the bottom. So let's type that in and see if we got it. Okay, and if you plug that in exactly how I typed it, you will get it correct. Okay, problem 5. Very, very similar. We have some function is ax plus b on top over cx plus d on the bottom. Let me use parentheses to make it more clear. This will be little f, this will be little g. So f is ax plus b, where its derivative is just a. G will be cx plus d, its derivative is just c. So again, the letters in front of the x's will stick around. Any constants like b and d will go away in the derivative. So that would be the derivative there. We're going to use fig minus gif again over g squared. So we're going to get the derivative of the function is f prime, which is a, times g, which is cx plus d, minus g prime, which is c, times f, which is ax plus b, all over g, which is cx plus d squared. Okay, the top, when we expand this, is going to be acx plus ad minus acx minus cb, all over cx plus d squared. And you might notice that acx minus acx will cancel, and so we'll get ad minus cb all over cx plus d squared. So that should be the answer simplified. And we type in that ad minus cb over cx plus d squared, and we get it correct again. Okay, problem 6 says the curve y equals 1 over 1 plus x squared is called a which of Maria Agnesi. Find the equation of the tangent line to this curve at the point 1, 1/2. So we have to find the derivative. Our y function is 1 over 1 plus x squared. So we're going to call the one on top f and this on the bottom g. So we're going to get f equals 1. Well, f prime of that's going to be 0. Derivative of a constant is 0. G is 1 plus x squared. Therefore, g prime is 2x. So we plug this into fig minus gif over g squared. And we're going to get fig is 0 times g, which is 1 plus x squared, minus g prime, which is 2x, times the original f, which is 1, all over 1 plus x squared squared. This whole first term will go away because 0 is multiplying it. So we just get negative 2x on top and 1 plus x squared squared on the bottom. Now they want us to find the equation of the tangent line to the curve at the point 1, 1/2. So they want us to plug in x as 1. And the y value for that function is 1/2. So this is like y1. So we're going to get the equation is going to be y minus y1 equals slope of the tangent line times x minus x1. But the slope of the tangent line is also, it's this function at x equal to 1, the x value of the point. So let's plug in 1 into this function. We would get minus 2 times 1 over 1 plus 1 squared squared. Well, that's going to be negative 2 on top. This would be 1 squared, which is 1. 1 plus 1 is 2. 2 squared is 4. So this is minus 1/2. So we get y minus 1/2 equals minus 1/2 x minus 1. So we get y equals minus 1/2 x plus 1/2 from the minus half distributed into the minus 1 plus another half from bringing the 1/2 on the left side over. So the slope of the tangent line should be minus 1/2 x plus 1. Okay, so let's type that in. It's minus 1/2 x plus 1. And then which graph should it be? So the only one that makes sense, it has to start at 1 and have a slope of minus 1/2. So it has to go down and to the right. So the top right's out, the bottom left is out. Those slopes are way off. This slope is 0, this slope is positive 1/2. So it's between these two curves. And they have to touch this curve at 1, 1/2. This one's over here at 3. This one's not even close. It's got to be this one. I don't know why they call it Witch of Maria Agnesi. Maybe because it looks like a witch's hat, I guess. That could make sense. Okay, so that's problem 6. Okay, problem 7. Suppose that f of 5 equals 1, f prime of 5 equals 4, g of 5 equals negative 7, and g prime of 5 equals 5. Find the following values. F g prime of 5. Okay, in problem 7, they want us to use, and I'm kind of amazed that I hadn't shown you this yet, they want us to use another rule called product rule. So we looked at the case of two equations being divided. This is the case of two functions being multiplied. So we're taking a product of two functions, not a quotient. The derivative is just f prime of x times g of x plus g prime of x times f of x. And just like quotient rule, we're going to abbreviate that with fig plus gif. So it's kind of very similar to quotient rule. Okay, so that's product rule. In fact, that's the first one they want us to use. So they want us to find fg prime of 5. So they want us to use fig plus gif, where they have told us that f prime is 4. They told us g, the original g, is negative 7. They told us g prime is 5. And the original f is 1. So it's the numbers in red. It's the y values that I'm plugging in here. So this derivative should be negative 28 plus 5, which is negative 23, which is what we have right there. Okay, then in the second one, they want us to use quotient rule again. So they have f over g prime evaluated when x is 5 would be fig minus gif over g squared. They told us f prime at 5 is 4. So this would be 4 times the original g, which was minus 7, minus g prime at 5, which is 5, times the original f, which is 1, all over the original g, which is negative 7, squared. So this is going to be minus 28 minus 5 all over minus 7 squared is positive 49. These two negative numbers will combine and become minus 33 all over 49. Okay, in the next one, let me not erase this because it might be easier to see this next one. They want us to do g over f prime evaluated at 5. So all we have to do is swap the letters from fig minus gif. So instead of f prime, it's now g prime. Instead of g, it's now f. Minus g prime is now f prime times f, which is now g, divided by not g anymore, f squared. And these numbers are now g prime, which is 5, times the original f, which is 1, minus f prime, which is 4, times the original g, which is negative 7, divided by the original f, which is 1, and we're squaring it. So this would be 5 plus double negative 28 all over 1, which is just 33 over 1, which is 33. Okay, so that's how we're going to get those for problem 7. Okay, problem 8, if f and g are the functions whose graphs are shown, let u of x equal fx gx and vx equal fx over gx. Find u prime at 1, find v prime at 5. So this is just wanting us to do quotient rule and product rule again. So the first one, u of x is the multiplication of f and g. Don't need that parentheses there, I'm not sure why I wrote it. Wouldn't have to have it, the outside one. U prime therefore is just going to be f prime g plus g prime f. Now, with these straight lines, we're going to have to get the derivatives by looking at the slopes of these lines. And where did they want this evaluated? They wanted this at 1. So we're going to x is 1, which is right here. And we're going to the, let's just get the regular numbers. So f prime, not sure yet. G at 1 would be the blue line, and it's the y value right here, which would be also 1. G prime, we're not sure. What about f? F at 1 would be this purple, at this purple line, and the y value is 2. So that's the easy part. The hard part's getting the slopes from these lines. So we have to go at 1, and we have to say, okay, f prime, it would be the slope at this line right here. So let's just count it. So the slope of this line would be, it rises by 1, 2, 3, 4, and it runs by 1, 2. So that's the slope of that blue line right there. Let's look at the slope of the g line at 1. It would be right here. Well, that slope is defined right here. So it decreases by 1, 2, so it's negative 2 on top. And it runs by 1, 2, so it's also 2. So this whole thing is going to be 2 times 1 plus negative 1 times 2. This is going to be 2 minus 2, which is 0. So all that work, and the derivative is 0. Okay, now they want us to find v prime at 5. And v is described as f of x over g of x. So v prime is going to be fig minus gif over g squared. Okay, now maybe I'll write this over here. And these are all being evaluated at x equal to 5. So we need f and f prime. We need g and g prime, all when x is 5. So now we're only going to care about 1, 2, 3, 4, 5. This line right here. Okay, so g at 5 is again 2. So g at 5 is 2. f at 5 is 1, 2, 3. So f is 3. What about the slopes? That's the harder thing to find. G prime, going back to the last point where it crosses, is right here. It is going to, and then the next place it crosses is right at that dot. So let's find the slope between these two dots. Well, it rises by 2. This is G prime. It rises by 2, and it runs by 1, 2, 3. So that's 2/3. Now let's look at f prime. F prime at that spot would be right here. Well, it's the other dot that we're gonna look at is right there. It drops by -1, and it runs by 1, 2, 3. So the slope there is -1/3. Okay, so putting that all together, we would have -1/3 times g, which is 2, minus g prime, which is 2/3, times f, which is 3, all divided by the original g, which is 2 squared. So we're going to get on top -2/3 minus 2/3 times 3. I'm actually going to write this as -6/3 all divided by 4. This is going to be -8/3 all divided by 4. And what we're going to get is -8/3 divided by 4/1 is the same as -8/3 times 1/4. This is going to be -8/12, which simplifies to -2/3. Okay, so the derivative there should be -2/3. Kind of a challenging problem, to be honest with you, because you have to understand fully what is the derivative. It's a slope of a tangent line. So with straight lines, it's literally just the slope of the line. So you have to not only find the y value at that x value, but you also have to find the slope of that line that goes through that x value. Okay, so study that one carefully and reach out to me if you need help. Problem 9. Find equations of the tangent line to the curve y equals x minus 1 over x plus 1 that are parallel to the line x minus 2y equals 2. Smaller y intercept, larger y intercept. Okay, tangent line. So that's derivatives. So we need to first find the derivative. And we're going to call this whole thing f, this whole thing g. Therefore, we have f is x minus 1 and f prime is just 1. We have g is x plus 1, therefore g prime is also 1. So y prime should be fig minus gif over g squared. So we're going to get f prime, which is 1, times g, x plus 1, minus g prime, which is 1, times f, x minus 1, all over x plus 1 squared. Now hopefully we get a lot of stuff to cancel on top. Distribute the 1, we'll get x plus 1 minus x plus 1 all over x plus 1 squared. Those x's do indeed cancel. The 1's combine, so you get 2 over x plus 1 squared. That is the derivative. Okay, now we want parallel to the line x minus 2y equals 2. So this line, first we're going to solve this, so we get negative x plus 2. Then divide everything by minus 2. We'll get 1/2 x minus 1. So the slope is 1/2. Now for these tangent lines to be parallel, they also have to have the same slope. So they have to have slopes equal to 1/2. Okay, so we're going to set this whole thing equal to that slope of 1/2. Let me just make a quick check to make sure I did this correctly, got the right slope. Okay. Yeah, it looks good to me. Okay, so we're going to just set this equal to 1/2. And so we're going to cross multiply here, and we're going to get 4 equals x plus 1 squared. Then we're going to do a trick from college algebra where we're going to say, to get rid of this square, I'm going to square root, but I have to add plus or minus to that when I do it. So we're going to get, we get two equations. One is positive 2 equals x plus 1. And one is negative 2 equals x plus 1. So the x plus 1 squared, the 2 goes away, it just becomes x plus 1. But on the left side, I get two answers, plus or minus 2. So I have two equations. This one is going to be subtract 1 from both sides, 1 equals x. This one is going to be subtract 1 from both sides, minus 3 equals x. So those are the x values for the points where we have a parallel line situation. So now, but we have to come up with the actual equations. So what we're going to have is, this is a lot of work actually. Okay, I hope I have enough room here. We have to use the formula y minus y1 equals slope of the tangent line x minus x1. And y1 is going to be the original equation evaluated at these two x values we just found. So we have to plug these into the original y function. So let's actually do that. It's going to be x is 1, so you get 1 minus 1 over 1 plus 1, which is 0 over 1, which is 0. So y1 in this first one is 0. Equals m tan, that is this 1/2. So it's going to be 1/2 x minus x1, which is 1. So this is going to be 1/2 x minus 1/2. That's one equation. Then we plug negative 3 into the original equation. So we get minus 3 minus 1 over minus 3 plus 1. Negative 4 over negative 2, which is positive 2. So we get y minus positive 2 equals 1/2 x. It's going to be minus 3, so it's going to be plus 3. This will be 1/2 x plus 3/2 plus 2. This is going to be 1/2 x plus 7/2. Okay, so those are the two equations, and we just have to plug in 2 is really 4/2 plus 3 would be 7 over 2. That's correct. Okay, so we just have to say the smaller y-intercept is minus 1/2, so this would be 1/2 x minus 1/2. Then this one's going to be 1/2 x, and it's going to be plus 7 over 2. So they have the same slope, and they have different y-intercept values. So we used quotient rule. We used, this is called point slope form with a derivative as the slope of the tangent line. And then we use two different x values to get two different equations that are parallel that have different y-intercepts. Okay, last problem. Determine whether the statement is true or false if f and g are differentiable, then the derivative of fx gx equals f prime x g prime x. No, this one's easy. So the derivative with respect to x of fx times gx, this is product rule, equals f prime of x g of x plus g prime of x times f of x. So they forgot, well, they basically butchered this in two ways. They forgot a whole second term, and they just did the derivative of both at the same time, which is not how you do it. So this will complete Chapter 3, Section 2.